they're written out as rows and columns. It's a grouping symbol of putting out things. And remember when we talked about this before, we used the coefficients of systems of equations. It's one of the things that we looked at it with. When you're working with matrices, a lot of times you're talking about their dimensions. They have rows and they have columns. This one has 2 rows and 3 columns. So you would call it a 2 by 3 matrix. Okay, that's the way that they write it out. Rows go first, and then columns. The numbers that are inside them are just called entries. They don't have a specific place or value or anything like that. They're just called an entry. Let's see, what else is there with them? Use this.
He's got nowhere to go now. He's got nowhere to go now. Oh no, what is this? What is it? I got you, fam. Oh, I got you.
It's the biggest. He's out of here. He's on the board. Get him. Kill him.
Hit him hard.
Oh, really?
Wait. No, guys, there's a way you have to kill a fly. You have to clap above it because your first instinct is to fly up and then out. So you have to like out after that. I'm good with this stuff. Where is it?
Just go down the door.
Top of the door. Oh, that's not it. Yeah, it is. Yeah, it is. Oh, I got it. That's not it. I got it. It's out of here.
Anyway.
This is you. I got it. There's 2! They're cornered! They're low. Guys, it's not even a fly. Oh. Oh, it's not? Where is that fly at? It's okay, I didn't need to say this to anyway. That's so sad. Broken to pieces.
Oh, I was about to take your homework.
That's my journal. You can just from humanity. That's so scary. It was like moths on the window.
Yeah, whatever.
Easier. Yeah, I think that was.
I squished them dead.
They know they're holding it. Oh, let's dissect it. I think it's small. I want you to have our tools in that.
Alright, anyway, so now that we got that out of our system. So we have rows and columns. Remember that goes rows, then columns, because rows, you row horizontally. You can't row a boat.
Are you on that?
No. Because if you were rowing a boat vertically, you'd be dead because you're going over Niagara Falls. So rows go left and right.
Well, they always say you're going down.
Don't worry about all the different types here. I just want to show you what they're called because you ever see it.
Oh, I remember using these.
You have what's called a row matrix, a matrix made of a row. A column matrix, a matrix made of a column.
Wow, I like square matrix.
Square matrix is one that has the same number of rows and columns. 2 by 2, 3 by 3, by 4, so on and so forth. Zero matrix. There it is.
Wait, so that's not a
Real fast, we're looking at that row one. Since there's only one row, this would be called a 1 by 4 for the dimensions. This is a 2 by 1. This is a 3 by 3. This is a 3 by 2, and so on. Just want to show you guys what a little bit of those look like.
Wait, isn't that a 2 by 3? Yeah.
Rows, columns.
Yeah, so.
3 rows, 2 columns.
I got you.
Okay. In order to do what we're going to do next with the matrices have to have the same dimensions, 2 by 2, 3 by 2, 3 by 4, whatever, in order to add or subtract them. Scalar multiplication doesn't matter, you're just distributing. But multiplication, which we'll talk about here in about 10 minutes or so, there's a specific rule that happens. So let me show you what happens. We're going to do stuff like this. I know this is a lot of work. If I'm looking at that first one, it's a 3 by 1 plus a 3 by 1. Are those dimensions the same?
Oh, yeah.
Yes. Since the dimensions are the same, your answer here is, now bear with me, 3 plus 1.
4.
Negative 4 plus 0.
Negative 4.
10.
Hey, he didn't say 7 plus 3.
That's your
It's
answer.
almost like a degree.
Oh.
That's Okay. The next one, are the dimensions the same?
Yes.
Yes.
So you just have to match up the entries. When you match them up, top left.
Minus 2, I mean.
What's 8 minus 2?
6.
3 minus negative 7.
10.
10.
4 minus 6.
Negative 2.
Negative 2.
And then
Negative 2.
Stop.
remember, the biggest problem, or biggest thing you're going to screw up is you're going to forget that minus and negatives that you're adding, just something stupid. Okay. The last one, can I do that?
No.
Because they're not the same dimensions.
No.
Sure. No. Wrong dimensions.
No.
Okay.
Nothing.
When you're dealing with these things, I'm not even going to bother wasting my time going through all that one, but if you look at this, that just means 3 times all of it. Just distribute out.
So it's just like glorified parentheses.
Yep. It is kind of like that. We use scalar multiplication. They use that when you're using matrices as dimensions, or not dimensions, as ordered pairs. What you can do with ordered pairs is that you can put them into a matrix and you can move them. You can add, you know how you can move in the 2-dimensional space, if you plot a graph of a triangle, you move it over to the left and you move it up. You can do that all via matrices. It's called vectors. It's using vectors to do this. You can do the scalar, which is just making them larger or smaller by using fractions. It's not very difficult. It really is not. Yeah, division-wise would be something like this. You'd be multiplying it by 1/3. See what I'm saying? Then you do that, just shoot it through. You can also do the following. Solve the equation. Here's what's happening. This looks really, really weird for something that is silly, silly easy. What you have here is that you got to make all of this stuff look like this. So what that means is, if I'm looking at in terms of ordered pairs and the way that the parentheses and the grouping symbols and stuff are shown, it's 2 times 3x plus 4 has to equal 26. What I'm doing there is I'm taking that 3x plus 4 and the 26, they're all in the top left of the matrix. And then the 2 is the scalar out front.
2 times negative
Okay.
1 plus 1 plus 0.
I do the same idea, it'd be 2 times the negative 1 plus 1 has to equal,
0.
does it?
Yeah. 2 times 0.
2 times 8 plus negative 2 has to equal 12.
Yeah.
Okay, see what's going on here?
Wait. So you just solve for x and y.
Yeah.
Wait, so why can't we just like do the first and the last one and then?
And I see where you're going with that. Would you have to write all of that out? No. Just like Chris was saying, why don't we just solve for the ones you need to? So all I would write out is that top left and the top right, top left and bottom right. It's the only ones that bother with. Because here x is going to equal what, 9? No, 3. Excuse me.
Yeah, isn't it 1?
No, y.
Why would I do that?
No.
Oh.
The letter y.
Yes. Yes.
And then that's how we get 8.
Remember, all I did here was divide by 2. 3x plus 4 is 13. X is 9. Or sorry, 3x.
Wait, what is that? I'm confused by this. Wait, what is No, the y. I'm confused how you got 8.
Where?
Oh, wait, negative.
It's right here.
Never mind. Wait.
I'm just matching the entries. I'm just matching them up. They all have to, the entries, if they're set equal to each other, means the matrices have to be equal. That's all this. Did you write it down wrong?
No, I just keep, okay, so 1 is equal to y.
Right.
So negative 1 y in the picture. 8 plus negative 1.
What?
Alright, x equals 3.
Let's go through all the steps on us.
I think I'm just messing it up.
Negative y equals negative 1.
Okay. And then you said add them, right?
So then you get 2 times 5.
No, you do the 5 plus.
Oh yeah, sorry, yeah, order of ops. Order of ops, you get 2 times 20, 5 minus 1.
Oh.
8.
Oh, okay. I didn't do
You were
that.
doing it the order of ops. You're doing the 2 times 5, and then you're adding the 1. That's why you're working it, right? Because the innermost parentheses, you're working your way out.
Yeah.
That's a lot easier than this. 4. What's up?
Oh, yeah. I see.
We can make this tougher if you want.
Ah.
All right, take a minute and do that one.
So, first one.
I'll do that, Yeah. It's like you just have to find the like steps. Go through that one again, please.
Could you explain
Number the y.
What's negative 1 plus negative 7?
It's a joke.
Yeah. Let's do the fun stuff. Let's multiply.
Wow. 4.1 is kind of challenging. I don't know if I can handle 4.2.
We'll pace ourselves. Multiplying.
Wait, didn't we just do that?
No.
We did add.
You did scalar multiplying, which was distributive property.
Okay.
Multiplying matrices is a whole different game.
Is it really?
No,
Math rice.
it can be very weird if you're not used to how you set it up. And third hour we did it, and they looked at it like, oh god. Just take a deep breath. I don't do the way the book shows it. I don't do it the way most people even do this. When I first started working with matrices was when I was in college, really, because I don't think we did a lot of it in high school. And it was an intermediate algebra class. It was like a 240. It was like your first foray after calculus into some of the weird matrices or weird math stuff, which was vectors and all this eigenvalues, eigenvector. I was just remember it. No, that's stats. And one of the first sections was working with matrices, and like you said, 4.1, that was easy. We got to this then with multiplying, and I was just headstrong. I couldn't get it to work because I kept trying to find the literal equation or literal values of the process the book shows and taking these, and it just couldn't keep anything straight to save my life. And my wife, who was my girlfriend at the time, she was always really good at matrices. And she's like, let me show you the way that I learned how to do it. It's a real nice trick. And it's worked ever since. And that's the only way I ever do these because it makes so much sense. It takes all the BS out of the problem. And it's just a pattern that you follow. The only thing, what's that? She did her 10-mile race this weekend.
Really? How'd you do?
Great. She did like 145.
Did you like it?
She loved it. As I digress. When you're multiplying matrices, you have, let's just say, you have rows by columns in the first matrix times some other rows by columns in another matrix. When you're adding and subtracting, you have to have exact dimensions. When you are multiplying, this is the rule you have to have. the number of columns in the first and the numbers of rows in the second have to be the same. Okay? So if this is a 3 by 2 and a 2 by 4, are the number of columns in the first one the same as the number of rows in the second? When this is a yes, as they're the same, the matrix, when you multiply it out, will have the dimensions of the outer numbers. So the new matrix would be 3 by 4. Okay? Now to start, I'm going to go with just 2 by 2s times a 2 by 2. So let me show you another example here of the numbers. Can I go to another one real quick?
Yes.
Oh wait, it's no big deal. So if I have a 1 by 3 and a 3 by 7, can I multiply them together?
Yes.
Yes, because these are the same,
1 by 7.
and your answer would be
1 by 7.
1 by 7. Now if I have a 2 by 2 and a 3 by 2, these aren't the same, so I can't do it.
So do you just say like?
So just say no.
So you just take like outside ones? If it works, you just take like the outside ones?
Yep. Well, if it's going to work, if these two numbers are the same, this is your answer. Okay? Those two numbers are the same, that'll be your answer.
How do you write like, since 1 by 3 is written as 1x3 1 times 3, how do you write this time since we'll put parentheses?
A lot of times what they do is they just put matrix like that.
Oh, yeah.
And then you have to figure out the dimensions. Okay? So let me show you an example. I'm multiplying these two matrices together. And I'm starting it with something that I know is going to work. A 2 by 2 times a 2 by 2 will give me a 2 by 2. So we know that's going to work. All right? Now here's my trick. Let me put this on a fresh one so it's more space. When you're multiplying matrices, you know that this is a 2 by 2. It's going to give you a 2 by 2. How many columns will the new matrix have? 2. So here's what I want you to do. Since it has 2 columns in the new matrix, I want you to write down the first matrix twice. Now you have to space this out a little bit. I want your next part here to look like this. I'm just spacing it out a little bit. I know. Like I said, this looks weird to start, but there's a reason that I'm spacing it out. Once again, I know that my result matrix, when I multiply a 2 by 2 times a 2 by 2, it's going to give me a 2 by 2. The new matrix is going to have 2 columns. Therefore, I write down the first matrix twice. If the new matrix is going to have 4 columns, I'd write down the first matrix twice.
So it's the number of columns.
Okay? Now here's what we do. This is a great little shortcut pattern. I start with this entry in the top left of the second matrix. I write it down. I go to the next one below it. I write it down next to here. I go to the top, the next one, and I write it down here. And then lastly, I put this one here.
So you don't go like match. You don't like match them up.
Nope.
You go
Nope.
across.
I'm working my way down, working my way down.
Wait.
I start at the top, work my way down to fill in those. Okay? Between these two, I put a plus sign. And here. Because if you notice now, this is going to give me top left entry, top right entry. Down here, I duplicate that 1, and I duplicate this. I do the same thing here.
So you're like multiplying the column by the row.
Yes. And that is the rule. But when you write it out, going columns and rows and filling them all through, it's
I feel
messy.
like you'd be more confused
Right.
if you had to do it
Yeah, that's why I don't do it that way. It gets to be a little messy.
Girl, saint.
How's your eye?
Much better. So now, what's 3 times 1?
3.
Plus 2 times 2. So the top left is going to be 7. Negative 1 times 1. Negative 12 plus 2. And this will be, here's my answer.
It's a negative 12 plus 2.
Negative 12 plus 2.
Yeah, we can put 10. Right.
That's all it is. And that's the mistake that you're going to make. You'll miss a sign. That's it.
This is pretty
All right.
hard.
I think I did just
Right?
So
Right
I'm
on.
thinking about, like, if he never would have found that girl, we would have struggled so bad.
Bless her soul.
A true angel.
Bless her soul.
Bless her soul.
Your marriage has saved lives.
Yes.
And grades.
Merry Christmas. Right on.
You're welcome. Let's go.
Yes, ma'am.
Wait, too much on it. Oh, so if it doesn't have the same amount of like the one
Right. The number of columns in the first one has to equal the number of rows in the second. If it doesn't, you can't. Okay? So this one's a 2 by 2 times a 2 by 2, which means you're going to get a...
6 by 7.
So how many times do you have to write down the first matrix?
Twice.
Twice. Negative 6, 0, 2, 3, 6. Now, what do I put next to the negative 6?
You get 1.
What do I put next to the negative 2? What do I put next to the negative 6?
4.
And?
3.
And once you get those in that order, below them, you just repeat it.
This is so cool.
So we have 6 plus 10. Is that right?
Oh, that's negative 6. Sorry.
This is
What?
Yeah, it is good.
Yeah, it's the only thing. It just takes up space. Matrices aren't difficult to work with, but when you do the work by hand, which of course I'll make you do, it just takes up space. That's all. Let's see. Wait, what? All right, let's do this. So I have a 3 by 2 and a 2 by 2.
Oh, no, I get why it's the number of columns and the number of rows.
What's rows then columns?
No, I mean like the number of columns has to be the same as the number of rows.
Is
Now I
that what
get
you
why.
know? Because now you know how many times you
Yeah.
write down. That's exactly why.
Okay.
Can I multiply these two together?
Yeah.
Yes.
Let's do it too.
These work, which means I'm going to get a So how many columns would the new matrix have? 2. So how many times did I write down the first matrix?
Why?
Twice.
Wait, how do you know how many times we've done this?
Whatever this number is the number of times you write down the first one. Okay, it'll work every time. And then again, I start at the top and work my way around.
You always just put plus sign between.
Yeah. Yep. So, with any luck, shouldn't be bad.
It's not.
Just lots of
Somebody in trees.
Cross the bridge.
Should move.
How can I make sure that I get things? Okay, that's today.
Oh.
2 plus 12 is 14. I have to do it out loud. I'm sorry, guys.
You literally just said you already finished doing it.
I remember, right?
5 plus negative 12.
No way.
14 plus 16. Negative 14 plus 16 is 44. 46. 46 minus 15
His answer's up there.
is 31. Oh God, I wasn't even looking at it. Well,
I probably just had added.
what did I do so wrong in the second one? And the third one.
See what I'm saying? Matrices make you have to have a little bit of attention to detail. Just a little bit.
I don't have any attention to detail.
Now, you need to work.
It looks like it's one smiley face.
What is the chance that today for our Spanish project, we had to do this fashion show, and we had to wear a specific outfit? I didn't even think about it, but I wore that outfit. Like, I wore a red t-shirt, jeans, and black flip-flops.
Keep it going.
We're not going to listen to an hour of Jeopardy.
You know, I almost wore a gray sweatshirt today.
All right.
I almost wore different jeans.
Here's what I want you to do. I said, here's what I want you to do. I didn't say it like that today. So,
What was the answer?
Oh, here, I have it.
it was this.
Okay, good.
Okay, 33, 36, 27. Oh, I didn't have Spanish homework. Yes, I'm gonna do the lab.
No, it's next.
If you did have Spanish homework, we used it to mask for a fly.